Dad, what are you doing?
I'm making a bonfire. Do you know that wood used for a bonfire is made of carbon, a non-metal?
A non-metal? What's that?
There is a class of elements known as non-metals. By the end of this lesson, you will be able to list the uses of non-metals, state the physical properties of non-metals, and list the chemical properties of non-metals. Look, to light this bonfire, I'm using a matchstick. The head of this matchstick is coated with phosphorus, a non-metal. The oxygen in the air that we breathe is another example of a non-metal.
Look, Dad, an orchard. What's the farmer doing?
The farmer is adding fertilizers to the trees so that the trees grow well and bear fruits. Fertilizers contain non-metals like sulfur, phosphorus, and nitrogen.
Why are you adding those tablets to that water?
These are chlorine tablets, which give out chlorine gas that purifies the water. Chlorine is another example of a non-metal.
Ouch! I've cut my finger.
Let me apply some antiseptic. Do you know antiseptics contain iodine, which is a non-metal?
Look, Dad, firecrackers.
The local villagers must be celebrating a wedding. Do you know that non-metals like boron, sulfur, and nitrogen are used in making crackers?
I see that non-metals have a great deal of use in our everyday lives. How does one identify non-metals? Do they have any distinguishing characteristics?
Yes, like metals, non-metals also have typical properties, which may be categorized as physical and chemical properties. The physical properties are more readily observable in our daily life. Non-metals exist in all the three states: solids, liquids, and gases. For example, silicon and carbon are solids. Bromine is a liquid. Chlorine, fluorine, and oxygen are gases.
Wow! The aluminium packaging is shining.
Yes, but unlike metals, non-metals do not shine. They have a dull appearance. For example, the surface of sulfur and phosphorus do not shine. Try to break this piece of charcoal into smaller pieces.
I did.
Do you remember the blacksmith near our home hammering red-hot pieces of metal into flat tools? Metals can be hammered into sheets, but non-metals break into pieces when hammered.
What are you doing?
I'm trying to tie the tent using this piece of metal wire. It is stronger than a rope.
Can wires be made of non-metals too?
No, non-metals except for carbon fibers cannot be drawn into wires. They are non-ductile.
Why are we using a cloth to remove it from the fire?
This kettle is made of metal, which conducts heat very well. That's why the handle of the kettle is too hot to touch. Unlike metals, non-metals are not good conductors of heat. For example, sulfur and phosphorus do not conduct heat. Watch this.
Wow! I see the electric bulb glowing.
The iron nail is a metal, so it conducts electricity. Now, replace the iron nail with a piece of charcoal.
The bulb is not glowing.
That's because non-metals do not allow electricity to pass through them. Graphite, being a non-metal, conducts heat and electricity. This is due to the presence of free electrons. You hear that noise when I hit the nail with this hammer. Metals make a typical ringing sound when hit with hard objects. Try to hit this piece of charcoal.
It's broken to pieces.
Non-metals do not produce any ringing sound when hit hard, but they break into pieces. For example, carbon turns into powder when hit hard. When you make a bonfire, the wood burns to release smoke. Non-metals react with oxygen and form acidic or neutral oxides. For example, sulfur reacts with oxygen to form sulfur dioxide, which is acidic. Let's perform an experiment to understand this chemical property. Take a small amount of sulfur in a deflagrating spoon and heat it. As soon as the sulfur starts burning, introduce the spoon into a gas jar. Then, cover the jar with a lid to ensure that the produced sulfur dioxide gas does not escape. Remove the spoon after some time. Add a small quantity of water into the gas jar and quickly replace the lid. Shake the gas jar well. Sulfurous acid is formed. Now, introduce a blue litmus paper which turns red. The sulfurous acid turns the blue litmus to red. This indicates the acidic nature of non-metal oxides. From this, we can conclude that non-metal oxides are acidic in nature. Observe the bonfire.
Why?
In this bonfire, if there is a partial combustion, carbon monoxide is produced. This is a neutral oxide. Nitric oxide is another example of a neutral oxide. We don't need the fire anymore. Let's put it out.
The fire's gone, but the unburnt charcoal is left behind.
That's true. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus is a very reactive non-metal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Yet another important property of non-metals is that they do not react with acids. Let's look at this small experiment. Take some sulfur powder in a test tube. Add 2 to 3 ml of dilute hydrochloric acid or dilute sulfuric acid. There is no observable change. Unlike acids, bases do react with non-metals. The reaction of non-metals with bases is complex. For example, when chlorine reacts with a base like sodium hydroxide, it gives multiple products like sodium hypochlorite, sodium chloride, and water.
It was very interesting to learn so much about non-metals. Now, I will be able to identify the properties and uses of non-metals.